Hey guys, Dr. K here again. So today I'm going to talk about a friction related physics problem. So I have this setup. I have a 5m mass, and on top of that there's a m mass. The flow, there's a coefficient of friction, it's rough, so that's mu s. And then the interface between m and 5m, that's also rough. There's a coefficient of static friction mu s. The question is, what is the minimum force F that we need to apply to to start to move 5m? What is the minimum force that we need to apply so that this object 5m is gonna start to move? How do we find that? Okay, so if you just focus on the horizontal forces acting on m, this is the easiest way. Okay, just look at the horizontal forces acting on m 5m. Okay, I'm just gonna just look at the horizontal forces. So this is not a free body diagram. Okay, I'm just looking at the horizontal forces. There's F. That's what we need to find out. This is a quick way of doing the problem. Okay, and then between these two surfaces that interface, there's a static friction force, because we are looking for the minimum force that we need to start to move the object. So there's a static friction force that is against the direction of this applied force. So static friction force, that's going to be in this direction. So let me call that F1. And what about this interface between m and 5m? That's also rough. So there's a static friction force there as well. And that's also in the opposite direction. Okay, that's also in the opposite direction because this object is trying to move in this direction. Okay, then the force on this due to friction is in the opposite direction. Okay, so if I look at horizontal forces, again, this is not the free body diagram, it just shows the horizontal forces. I have that applied force, static friction force due to this interface, and static friction force due to this interface. Okay, now my objective is, how am I going to find F1 and F2? You should remember static friction force, or basically the maximum value of the static friction force, can be written as mu s times the normal force. This is a well-known equation in friction. Maximum value of the static friction force is equal to mu s, that's a mu, that's a Greek letter, and then s, that's a subscript, and the normal force. So let's use that to figure out F1 and F2. Okay, so F1, I told you it's this one. So I'll write down F1 mu s. What is the normal force? That's the question. What is the normal force for this surface? What should I put here, normal force? You need to think about it. Okay, the normal force, can you see? Both these masses are pushing in this direction. So it's not just 5m, there's 5m plus m, 6m g, because force, it means like m times g, right? So 5m g plus mg. So then we will have mu s 6mg. Okay guys, so that's this force, static friction force 1. Static friction force 2, that is due to this surface. So I'll write that F2, the same coefficient of friction, mu s, but this time the normal force between these two surfaces on this object is just mg. Okay, why? Because gravity is pushing down, and then this surface is pushing up on the object. And since it has no motion in this direction, gravitational force must balance the normal force, which is mg. So I'm going to write mg. Okay, that's F2. So then, in order to like start to move this 5m mass, F minus F1 minus F2 should equal to 0 at that limiting case. Limiting case, okay? So then you can write that force is equal to F1 plus F2. And then you can go ahead and substitute. So here F1 is, I'll factor out the number 6 mu s mg plus then F2, look, it's mu s mg. Mu s mg. So then I have 6 and a 1 here. So the minimum force that I need to apply for this object so that it starts to move the 5m mass is 7 mu s mg. 7 mu s mg. So guys, that's how you do this problem. That's the method. That's how you do this problem. I hope you learned something important about friction. And if you like these videos, hit like and then follow me for other new types of physics problems and pre-calculus, calculus type problems. Have a nice day. See you again, okay?